Hello, everyone. Okay, so for this video, we'll start looking into the details of each of the previously overviewed deadly wastes. We start looking at the first type of waste, which is defect. And I'm going to relate you what I previously learned, and then let's all together learn. Defect is any defined as any work that is basically less than the level the customer has requested. And these defects apparently ultimately plague our companies in many different ways. And while it's difficult to accurately quantify this cost of poor quality, as it's often called, we can attempt to measure its impact by looking at things like warranty costs, lost capacity, rework costs, field service repairs, and also even customers can be lost due to poor quality. All right. Now, the next question is 99% good? All right. The short answer for that is no, 99% good is not good enough. And in fact, if apparently if all pharmacies operated at 99% performance levels, meaning 1% are bad, they would actually dispense 20,000 wrong prescriptions each year. Compare that to around 68 per year at Six Sigma performance levels. Um, Likewise, operating at only 99% performance levels, it would equate to two short or long landings at the Dallas Fort Worth Airport each day. Compare that to one short or long landing every 5 years. Okay, so that's big. If they were operating at Six Sigma levels. And lastly, if the Postal Service performed at 99% defect-free levels, there would be around 400 lost articles per hour. And if we compare that to one lost article of mail per hour, if they operated at Six Sigma levels. Now, these are just a few examples, really showing how much we truly depend on certain processes to function at extremely high performance levels. Now, the next question we have here is what causes defects? Um, well, the first potential cause is the lack of in-process checks. Our ability to detect what this means is our ability to detect problems early in the process is crucial, since the longer a defect can move through the process, the more it costs us. And then another common cause of defects is low quality material from our suppliers. So apparently, if some companies spend millions, there might be already be some companies spending millions of dollars reworking things like castings before even thinking about adding value to their cost that their customer is willing to pay for. And then finally, some other causes of defects are inadequate training and poor or no work instructions. All right, that said, we go over to the what tools do we have that will help us to battle defects. The first technique that we can use is the stop the line principle, which basically means all employees are empowered and, in fact, encouraged to stop the production line whenever a defect is detected. So that's in an attempt to understand and address the root cause of the problem. And apparently, many companies experienced with uh, lean principles utilize andon cords, which are cables or strings that, when pulled, cause the whole line to stop after a short time. Okay, and then another powerful tool that we can use is called poka-yoke, also referred to as mistake proofing. Okay, what about that? The basic premise behind Poka-yoke is that we make it impossible or at least extremely difficult to make a mistake or produce a defect, much like it's difficult to place a square peg into a round hole. So imagine that. So the next tool available to us is 5Y analysis, which essentially has us asking why multiple times. So that's in an effort to really identify the root cause of a problem. And then we have another powerful tool, and probably one that we'll learn together later on is the fishbone diagram, where the defect is placed at the head of the fish, while all the bones of the fish are potential cost. And then next we have Jidoka. And Jidoka is also referred to as automation or automation with a human touch. Okay. The basic premise behind this Jidoka is that machines are able to detect when an issue has occurred. And once they detect an issue, the machine stops running while alerting the operator of the issue by flashing a light or sounding some type of alarm. So oftentimes, inexpensive sensors wired into a machine's controller are all that's needed to get started with Jidoka. Okay. Then lastly, we have the use of the Six Sigma methodology as another approach, as many organizations apparently have used it to battle and defeat defects. Then also by arming associates or employees with clear work instructions and standard work documents. So their chances of producing defect-free products are greatly increased. Okay, let's time check for a bit. We still have time for the next defect, which is inventory. All right. We start first by looking at its definition. Um, Formally defined, this waste of inventory is any material or work on hand other than what's needed right now to satisfy customer demand. And as you might imagine, inventory comes in many shapes and sizes. There is work in process, finished product, you have supplies, excess documentation, and even unread email is a type of inventory, right? Now, inventory is directly related to cash flow. So, in other words, if you've already converted inventory into healthy profits, then it's better really from a cash flow perspective. And it's the other way around if you have excess inventory that you've already paid good money for sitting on shelves taking up space. So you remember, let us remember that for any business, cash is king. And if you tie it up in inventory, it is not available for you to use elsewhere in your business. And in addition to the physical costs of your inventory, you also have a host of less obvious costs that are cut directly from your profit. These are areas such as transportation and movement of this inventory, the space required to store it. You have the containers to store it in, even the administration of keeping track of it, and what else? The damage and losses that occur during transportation. You also have the cost of writing of materials that become obsolete. Wow. And even the cost of insuring it. So it doesn't look good really. Now we tackle about the types of inventory. Um, we start with cycle stock, and really it's inventory needed to cover normal demand. And this is calculated by multiplying the daily average by the lead time to replenish. In other words, if the lead time to replenish a part is 3 days and 1,000 units are needed per day, we do the math, the cycle stock will be 3,000. In this example, cycle stock must be enough for 3 days of steady average demand. All right. Hence, the two factors that influence the amount of cycle stock needed are the average daily demand and the replenishment lead time. Now you may ask, what about late deliveries, demand changes, and other unpredictable changes? So this is where the other two types of inventory, buffer stock and safety stock, come into play. So first, buffer stock. This is used to hedge against sudden unexpected demand surges. And then to calculate buffer stock, we use standard deviations to calculate the probability of demand surge exceeding a certain amount during the replenishment period. Now, there are many factors that influence the amount of buffer stock needed, such as forecast errors and demand swings. And then we have safety stock, which is inventory used to safeguard against parts being lost due to downtime, scrap, or other factors that are a reality in our world. Now, this number is calculated based on factors you select no, and measure over a period of time. That is sufficient to give you an idea of the maximum possible loss. Next, things such as scrap, rework, downtime, and late deliveries might play into the percentage you choose. And this is an area you'll need to continuously improve and update, as the fewer problems you have, the lower your safety stock inventory can be. Now, let's go to the cost of inventory. You see, most organizations vastly underestimate the cost of inventory, um, since it's much more than just the interest paid on the money to buy the material. In addition, there are costs to keep and manage the inventory, cost of obsolescence, cost of price erosion, opportunity cost for making products that are put in storage instead of making products that could be sold. And perhaps the greatest cost of inventory is the false sense of security that these buffers give people. So you see, when you have high buffers, your problems are often buried below the surface. Now, what causes inventory waste? The first reason is many companies making extra parts in case of scrap. So in other words, they're using inventory to mask things like quality problems or careless manufacturing mistakes. And then we have another cost of inventory, and this occurs when employees are measured and rewarded based on the number of units they produce, no matter if they're producing more than the customer is willing to buy. Next, we have unleveled or choppy production schedules that often make it very difficult to maintain consistent and healthy inventory levels. Then lastly, when companies attempt um, to build to forecasts, problems often arise since those forecasts, no matter the industry, could sometimes or perhaps many times be wrong. Okay. Now we have the tools also to battle inventory waste. And the first tool that we can use is SMED, which stands for Single Minute Exchange of Die. Now the basic premise behind SMED, which is often referred to as quick changeover, is to do as much of the setup while the machine is running, so that when the machine does stop, we can quickly get it ready to produce another part. And then also another technique that apparently many lean producers utilize to lower inventory and increase throughout is one piece flow. The basic premise with one piece flow, or make make one move one, is that each worker produces one piece and passes it on to the next process only when that process needs it. The work is balanced to tact time, and each operator is fully aware of what is happening upstream and downstream. Then next we have Kanban, which is yet another way to reduce the amount of work in process in any operation. As as we learn later on about Kanban, it's where we'll also learn about what is referred to as downstream pull system. Now, this type of pull system works by scheduling one process, in this case assembly, which then triggers a series of pull signals to the other processes before it. Okay. And there you have it, darling friends. We'll stop here for now and see you in my next video. And if you enjoy this one and you'd like to see similar videos in the future, of course, don't forget to like, comment, subscribe to my YouTube channel down below, and hit the notification bell as well so that you don't miss out on more learning videos. By the way, credits to the artist for the music in this video. Thank you so much. And bye for now.